Starting in section 3.3, we're going to talk about the intercepts, that means the x and the y intercepts for linear equations. So we'll be able to pick out the intercepts of a graph if we're given one, and then we'll also graph a line by finding two particular points, that would be the x-intercept and the y-intercept, and then we're going to end with finding the x and y intercepts of vertical and horizontal lines. All of the topics that we go through will always end with, okay, now how do horizontal and vertical lines differ? All right, so this is considered the x-axis, and the point where the graph crosses the x-axis is called the x-intercept. Where we cross the x-axis is the x-intercept. So for this graph right here, the x-intercept would be the point 3, 0. That's the x-intercept. X-intercepts and y-intercepts are points. All right, looking here, this is the y-axis. So the y-intercept is the point that crosses the y-axis, and that would be right there. And so that's when y is -6, so that's the point 0, -6. That's the y-intercept. So sometimes the information that you'll be given about a line is its x-intercept or its y-intercept. So you go ahead and look at practice problems 1 through 5. They've got some graphs, and you're going to pick out the x and y intercepts. Remember, x and y intercepts are ordered pairs. They're points. So moving on to classroom example 2, two of the easiest points to find for a line are the x-intercept and the y-intercept. Why? Because the x-intercept is always where y equals 0. This is the point 1, 0, 2, 0, 3, 0. This is the point -4, 0. The x-intercept is always where y equals 0, and 0 is a very easy number to work with because anything multiplied by 0 is 0. And the y-intercept is the point where x equals 0. All right, so here's the point 0, 1. Here's the point 0, 4. Here's the point 0, -6. Here's the point 0, -3. The y-intercept will be the point where x is equal to 0. So if we're going to fill in this chart, another way they could have asked this is graph using intercepts. So if I have 2 when x is 0 minus y equals 4, this is when x is 0. This is going to be the y-intercept. Anything times 0 is 0, so we have -y equals 4. Well, we don't want -y. Let's divide by -1, or in other words, let's change the signs. Y is -4. So not only is the point 0, -4 on the graph, we would say the y-intercept is -4, or the y-intercept is at the point 0, -4. Let's let y equal 0. In other words, let's find the x-intercept. 2x minus 0 equals 4. I'm substituting 0 in for y. All right, well that means 2x equals 4. Divide both sides by 2 and we get x equals 2. So that's the ordered pair 2, 0. Notice the y-intercept is on the y-axis. Notice the x-intercept is on the x-axis. And so if we use our ruler, graphing the line between the two intercepts, that is the line 2x minus y equals 4. All right, you're going to try practice 6. right, for classroom example 3, let's go ahead and try to find the x-intercept and the y-intercept. So the y-intercept is when x equals 0. That's this first row. So y equals 3 times 0, or y equals 0. All right, that's origin. That means that the y-intercept and the x-intercept are going to be at origin. I'll do row 2, even though I don't even really have to. Let's find the x-intercept. That's when y equals 0. 0 equals 3x, so if we want to get x by itself, divide by 3. So the x-intercept is origin and the y-intercept is origin. We have found our intercepts. The problem is we don't have enough information. We need two distinct or unique points to be able to graph a line. So we have to pick any other value for x and y. We have to find a second point in order to be able to graph this line. Doing it by intercepts was not enough because the intercepts were origin. They shared origin as their intercepts. So let's find the y value when x is 2. Y would be 6. So since we needed another point, you pick a nice, something that's easy to calculate. When x is 2, y is 6, and now that's enough to graph my line. Y equals 3x.